You know, the sneeze. We all do it. It's completely involuntary, and yeah, it can be a little messy. But what if I told you that this super common everyday reflex is actually hiding some of the most bizarre and fascinating secrets of human biology? Let's get into it, because there is way more to a simple achoo than you probably think. All right, we have to start with the big one. The most famous, the most dramatic myth of them all. The one you definitely heard on the playground and probably secretly wondered if it was true. I mean, really, think about it for a second. The pressure feels immense, right? Your entire face scrunches up. So, could it actually happen? It is a terrifying thought, and it turns out this myth has a shockingly specific backstory. And get this, that's a real headline. Back in 1882, the New York Times actually reported this horrifying story. This one single dramatic account is what's given this myth so much power for over 100 years. But as wild as that story is, the truth is a little different. Okay, so yeah, it's pretty much impossible. That case from 1882, an extreme rarity. And she almost certainly had a pre-existing medical condition. For the rest of us, the idea that a normal sneeze can just pop out your eyeballs is pure fiction. So the real question is, why not? The reason your eyes are totally safe has everything to do with the incredible anatomy that's anchoring them right into your skull. See, your eyeballs aren't just kind of floating around in there. They are strapped in tight by 6 really strong muscles and the thick optic nerve. And think about this. Even if you could somehow force your eyes to stay open during a sneeze, your eyelids are way too weak to contain that kind of pressure anyway. Your eyes are in there good and secure. Okay, so if our eyes are in danger of launching out of our heads, what is actually going on? Why does our body have this totally automatic and kind of weird reaction? It's what's called an autonomic reflex, which just means you do it without thinking. But it's not random. Your body is doing it for a very specific and honestly a very smart reason. It all starts right here. When something, dust, pepper, whatever, gets in your nose, it triggers what's called the trigeminal nerve. That nerve sends a signal straight to your brainstem, which is like the command center, and it orders a whole bunch of muscles to contract all at once in this perfectly coordinated response. And there are 2 main reasons your eyes slam shut. First, and this is the obvious one, it's a shield. Your body is instinctively protecting your eyes from all the stuff it's about to blast out. And second, it's just part of the whole package. The signal from your brain doesn't just go to your eyelids, it goes all over, contracting muscles in your face, your throat, even your abs. Your eyelids are just following orders like everyone else. And believe me, that protective shield is pretty necessary when you realize how fast this stuff is moving. A sneeze can shoot out droplets at up to 40 miles per hour. You definitely do not want that flying back into your own eyes. Okay, so we've busted the big myth, we've explained the standard issue sneeze, but now we're gonna get weird. What about those people who walk outside into the sun and immediately start sneezing? It is a very real thing, and it has a fantastic name. It's called the Photic Sneeze Reflex. And no, it's not an allergy to the sun or anything like that. It's a genetic trait where the trigger isn't dust in your nose, but a bright flash of light in your eyes. And because scientists apparently have a great sense of humor, it's also known as AH-CHOO syndrome, which is actually an acronym for autosomal dominant compelling helio-ophthalmic outburst. I mean, you just can't make this stuff up. And this isn't some super rare thing either. It's estimated that somewhere between 18 and 35% of us have this trait. That means there's a really good chance that you, or at least someone you know, is a photic sneezer. So what on earth is causing it? The most popular explanation is basically a case of crossed wires in your nervous system. It's all about 2 major nerves that happen to be located very close to each other inside your brain. So here's how it's supposed to work. On one side, you have the optic nerve. It senses bright light and sends a signal to your brain to make your pupils shrink. Right next door is the trigeminal nerve, the one we already talked about, which senses irritation in your nose and tells the brain it's time to sneeze. The theory is that in photic sneezers, these 2 nerve pathways are so close that a really strong signal from the optic nerve, like walking into sudden bright sunlight, can actually spill over and accidentally trigger the trigeminal nerve. So the brain gets the sneeze signal even when there's nothing in the nose at all. So what's it actually like to live with this? For most people, it's a harmless, sometimes kind of funny conversation starter, but not for everyone. For someone like Kimberly Pang, it's just a fun personal fact. She steps out of a dark movie theater into the sun, has a sneeze or two, and that's it. It's just a little quirk she shares with her family. But then you have people like Donggun An, and for him, it's genuinely annoying. He talks about these uncontrollable fits of more than 5 sneezes in a row that can actually hurt his throat. It's a good reminder that even a simple reflex can be a real nuisance for some people. And in some very specific high-stakes situations, this quirky little reflex can become a serious danger. I mean, imagine you're driving and you come out of a long, dark tunnel right into blinding sunlight. A sudden, uncontrollable sneezing fit could be catastrophic. The same thing goes for fighter pilots, where even a split second of being blinded could be fatal. So the humble sneeze, it's really far from simple, isn't it? It shows just how intricate and sometimes just how messy the wiring of our nervous system can be. And it really makes you wonder, studying a seemingly minor glitch like AH-CHOO syndrome could one day help us understand much more complex neurological conditions. What other little secrets are our bodies trying to tell us?